Hello everyone, we're going to go ahead and start continuing with our lesson on graphing compound inequalities, but today we're going to focus on the ones that have the word and. So we went over the ones with or, so let's see how the ands are different. So let's just go back quickly to the definitions. The one with the word or are the union of the two graphs. So let's go ahead and fill in the answer there. And it's pretty much where one of them is true. So we just pretty much graph the two, and anything that gets graphed is a solution because it will be true for one of the two inequalities. Now for the and inequalities, it's a little different. It represents, it's the intersection. The intersection of the two graphs, and we need to figure out where they're both going to be true. So it's not just graphing them like we did with the or, because it's where one is true. We want to figure out where both are true. So the idea is, where do they share answers? What answers do they have in common? So that's what we're going to be looking at. So we're going to be comparing the and inequalities versus the or inequalities. So let's go ahead and do that. So the ones on the left are or, and the ones on the right are and. I want you to notice that numbers 1 and 2 are almost identical. The only difference is the words and the words or. But the inequalities are the same. So let's look at number 1. We're going to graph this or inequality as usual. Put our circle on the 4, open. Less than means to the left, so we graph everything to the left. So -4, anything to the left of 4 is a solution, so 3, 2, 1, 0, everything is a solution. Now, the second inequality, we put an open circle on the 0. It doesn't matter because it's already been highlighted, so even if we put the open circle, it's really just a closed circle. So just as a FYI, it's been highlighted, and then this is a greater than, which means we highlight to the right, so we're re-highlighting to the right. Now that 4 is getting closed because I'm highlighting to the right. So really, at the end of the day, everything is a solution. So we get our real numbers here. So every single number is a solution. All right, same thing for number 2. Again, we have to be careful because it's an and inequality. One more time, it's the intersection of the two sets of solutions. So we are looking where they share solutions. So we can't just go straight to the graph. We have to be very careful here. So I'm going to go ahead and graph these two inequalities above the number line and see where they intersect, where they share solutions. So I'm going to go ahead and put a circle above the 4. And I'm going to go to the left again. Let's fix that real quick. Circle to the left of 4. Now I'm going to put a circle at 0, and I'm going to go to the right. So here are the two graphs separated above each other, because I'm looking where they share answers. So they share answers, and they intersect in this middle section. So that's where my actual final answer is going to be. Everything in between 0 and 4. So I'm going to put a circle at 0 and at 4, and I'm just going to highlight everything in between. So my solutions are 1, 2, 3, 4, and all those decimals in between. Let's look at number 3 and 4. Again, we have the same two compound inequalities, with the only difference being the or and the and. So let's go ahead and graph the first one. Since the number 3 is an or, I can just go directly to the number line. Anything's a solution if it gets graphed. So -3, closed circle is a solution, and anything to its left. And there we go. -1 is a solution, so I'm going to put a closed circle, and anything to its right. And I'm done. So everything here, solutions are here and there, and there's no solutions in that middle section. All right, number 4. Same inequalities, different word in between to connect them. So we're going to be doing an and. I'm going to graph them on top. So -3, I'm going to put my circle, and to the left. -1, I'm going to put my circle, and to the right. Now I'm looking, where do they share solutions? Where do they intersect or overlap? So just looking at this one does not overlap that one. There's nowhere where they share solutions. So in this case, I have no solution. Or no solutions. There's no solutions in this case, because they don't share any answers. So there is absolutely no x value I can plug in here and here that will make both of these true. So there's no solution. So that can happen. That's a special case of the and inequality. But most of your and inequalities will look like this one right here. And most of your or inequalities will look like this one right here. All right, let's go ahead and move on to the next one. Now, number 5, same thing, or inequality. We can go straight to our graph. At 0, open circle, and greater than to the right. So open circle to the right. All right, those are all solutions there. Now, at 3, close circle. And 3's already been highlighted by the arrow, so I'm just going to put a closed circle over it. Still a solution, and everything to the left, less than. So I'm going to go to the left. It's going to close that 0, and it's going to cover everything to the left. So here we have all real numbers again. Okay, we have the same inequality here, but with just the word and here. So let's go ahead and graph that. Again, it's an and, so I'm going to go above because I'm looking for where they share those answers. So again, I'm looking for that spot where they share answers. So at 0, I'm going to put a circle above, and it's going to be greater than. At 3, I'm going to put a circle above, then go less than. I'm going to look for where do they share answers. So they share and intersect in this middle section where they're over each other. So my solution is going to be between 0 and 3, both open circle, and just shade the centerpiece. So again, so my solutions are 1 and 2, and everything in between, 0 and 3, are not solutions. All right, let's look at number 7 and 8. These look a little weird because this is something kind of new for us. Notice that we have 2 inequalities here. So we call this a double inequality. And these double inequalities always represent the and compound inequalities. It's just a merging of the and inequalities. So we look at the top section, going back to our definition. If we look at this section here, that your and inequalities can be written in a specific way. So it can be written in 2 ways. This is an and inequalities. You can write it as the regular way with the word and in between, or you can write it as a connected inequality. So if you were to write it as a connected inequality, I want you guys to notice one thing. The 2 inequalities are facing the same direction. You cannot have 2 inequalities where it's facing opposite directions. This would not work. So they have to be facing the same direction, and then you should be fine. So these always represent the and inequalities, and they're actually easier to graph. So let's go ahead and graph number 7. The reason why is you don't have to worry about any of that overlapping. This pretty much means that x, or x here, is just any number in between -1 and 3. So you're going to just highlight everything in between the 2 numbers that you were given. Remember, this is an and inequality even though we don't see the word. So we're just going to highlight everything in between. So all the x values are in between -1, which is going to be a closed circle because of the equals here, and the 3 on the right side, which is also a closed. So you just highlight everything in between and you're done. So and inequalities are connected, like this one. It's just anything in between. Let's look at the last one. The only thing about the last one is this is not x. We have 4x plus 2. So we need to solve for x. So how do we solve for x? The same way you would solve for x if it looked like this. Don't cross this out. If it looked like this, the same way you would solve for x. You would subtract 2 and divide by 4. So we're going to go ahead and do that. We're going to subtract 2. But here, instead of subtracting 2 from the 4x plus 2 and the 22, we do it to the left side as well. So whatever you do to the left, you do to the middle, and you do to the right. Think about it as having 3 barriers here. So what you do to the left, you do to the middle, you do to the right. So now we're going to get -8. We still have our less than or equal to 4x, less than or equal to 20. If there's a number next to the letter, we divide. So we divide by 4, divide by 4, divide by 4. The 4's cancel. We have x Do we flip our inequality? We divide it by a positive here, so we do not flip the inequalities. They stay the same direction. That's going to be a -2 and a +5. So here we have our final inequality. So we're pretty much going to highlight everything in between -2 and +5. We're going to use closed circles. So we're just going to highlight everything in between. So -1, 0, 1, 2, 3, 4. 5 and -2 are all solutions and all their decimals in between. So that's pretty much it. Go ahead and get started on your practice. Be very careful to check if it's an or an and good luck.